In section 12.5, we're going to continue with our statistics unit, and we're going to work with percentiles as well as with z-scores. And so we're actually going to be able to tell what percent of a population is above or below a particular location. All right, percentiles. If n% of the items in the distribution are less than a particular data item, we say the data item is in the nth percentile of distribution. Okay, so that means if 25%, I'm going to use 25, if 25% of the items are less than your score, that means that you would be in the 25th percentile. If 98% of the data items are less than yours, then you're in the 98th percentile. There are some special percentiles. The first, right here, if 25% of the data is less than this is called the 25th percentile or the first quartile. Here, this is the second quartile, which is also the median, and it is the 50th percentile. This is the third quartile, and that is the 75th percentile. Okay, so quartiles, it does mean quarters. We won't really use that much in our work, but I did want you to be exposed to that language. This chart, an abbreviated form of this chart will be included in your homework questions, but this just shows, and this is standard for any normal distribution, that if you are 4 standard deviations, z-score of -4, to the left of the mean, then you are in the 3/1000th percentile. Teeny tiny. Let's go to, let's see, where is here we go. If your z-score is 0, what does that mean? We're talking about the mean. You're in exactly the 50th percentile. If your z-score is 2, you are 2 standard deviations to the right or greater than the mean, you're in the 97.72 percentile. Okay, so z-scores and percentiles, you don't have to figure out that percentile. It is in a table and it will be given to you. All right, let's look. I'm going to enlarge this so that we can see each one of these. All right, let me get some, whoops. Well, maybe I won't get any workspace. Okay, I won't. All right, number 1. Use the table below to find the percentage of data items in the normal distribution that A, lie below, and B, are above a z-score of 1.3. Okay, let's go look for a z-score of 1.3. It's right here. Now, it gives you no figuring out that it is the 90.32 percentile. So the ones that are below this score it is 90.32%. You have to do a little work to figure out what percent lie above. Well, I like to say it's the rest of them. So if you take all 100% and you subtract the ones that lie below that, you will get 9.68% are below. Are above. So 90.32% are less, and only 9.68 are above. The number that's given, the percentile that's given, is the percent that are below it. Remember, that was in our definition. the n% of the items in the distribution are less than a particular, then that's the nth percentile. All right, let's look at number 2. Use the table below to find the percent of data items that are below and above a z-score of 1. All right, here's a z-score of 1. Well, how many lie below it? Automatically, it is 84.13%. That's the percentile that it's in. How many are above it? The rest of them. 100% minus 84.13%. Do that subtraction, and you'll get 15.87%. All right, number 3. We're going to find the percent of data items in a normal distribution that lie below and above a z-score of negative 0.15. All right, negative 0.15. All right, for how many lie below it is 44.04%. On a bell curve, 44.04% would be to the left of this z-score. Okay, what percent lie above it? The rest of them. 100% minus 44.04%, and that gives us 55.96%. And I'm just doing the subtraction off screen. All right. Now we're going to change it up just a little. It says, use the table below to find the percentage of data items in a normal distribution that lie between a z-score of 0.3 and 2.8. All right, let's find those. 0.3 and 2.8. Well, it's really good common sense. You want to know what falls between them. Just take the larger one, 99.74, and subtract the smaller one, 61.79. The percent that is between them turns out to be 37.95%. So finding between is pretty easy. Number 5, find the data that fall between 0.3 and 1.5. All right, 0.3 and 1.5. Between. All right, so take the larger one, 93.32, subtract the smaller one, 61.79, those percentiles, and you will get that the percent between them is 31.53%. All right, number 6, we're going to have to do a little bit more work. It says the results of a certain medical test are normally distributed with a mean of 130 and a standard deviation of 17. A score above 142 is considered unhealthy. Okay, so the higher the score, the more unhealthy you are, I suppose. All right, use the given table to find the percent of people with readings below 139. They did not give me below a z-score. They said below a score. I have to convert my score to a z-score. So the first thing I have to do is find the z-score for 139. And I know that I'm going to take my data, 139, whoops, so sorry, just opened something accidentally. I'm going to take, let me push this up a little, and then I'll bring it back down. 139, I'm going to subtract the mean, which was given to be 130, and I'm going to divide by the standard deviation, which was 17. So those numbers were all given. 130 was the mean, standard deviation was 17. This is my formula, and it says that you get 0.53. Now, if I look at my chart, this is only in tenths. So I'm going to have to use my chart. This is closest to 0.5. Okay? So it wants to know, use the table to find the percent of people with readings below. Now I can say a z-score of 0.5. So I look at this, and I could say that associated with the z-score of 0.5, that 69.15% are below that z-score, which means below the actual score of 139. Okay, I'm going to have to do my work over here. Whoops. Number 7. The results of a certain medical test are normally distributed with a mean of 122 and a standard deviation of 16. A reading above 110 is considered unhealthy. Use the given table to find the percent of people with readings above 88. All right, the first thing I'm going to have to do is get a z-score for 88. All right, it's going to be 88 minus the mean, which is 122, divided by the standard deviation, which is 16. I get negative 2.125, and this is rounded to, this is only in tenths, so I'm going to say that this is approximately negative 2.1. All right, so now I'm looking for the percent of people with readings above a z-score of negative 2.1. Okay, z-score negative 2.1. It's right there. And it said the word above. Now, 1.79% are below that. That means the rest of them are above. So I will have 100% minus 1.79%, which means that I get 98.21% are above that. All right, we're just going to keep working on this. Hopefully it begins to feel very comfortable. And let's see, we have these test results again. The mean is 123, the standard deviation is 20. Convert the given results into z-scores, then use the table to find the percent of people with readings between 155 and 177. Okay, so I need to get the z-score for 155, which is 155 minus the mean, which was 123, divided by the standard deviation, which was 20. And I end up with a z-score of 1.6 for this one. Now I need to get the z-score for 177. Well, it's going to be 177 minus 123, still divided by 20. It doesn't want to keep an equal sign. And I get 2.7. So I need to now find the percent between these, between 1.6 and 2.7. And we talked about earlier, to find the percent between, you take the larger one, 99.65%, and subtract the smaller one, 94.52%, and that gives us 5.13% between them, and that's my answer. Okay, we have a couple more. All right, we're doing this several times so that you feel very, very comfortable with it. All right, this time we have our medical test results with a mean of 125, standard deviation of 20, and I want to find the readings between 153 and 167. So I need to do the z-score for 153. That will be 153 minus the mean, which is 125, divided by the standard deviation, which is 20, gives me a z-score of 1.4. Then I need to find the z-score for 167. So it's going to be 167 minus 125 divided by 20, and that gives me 2.1. I need to find the percent of the data that would be between these two z-scores. So between 1.4 and 2.1. To find between, I need to subtract. I take the larger one, 98.21%, and I subtract 91.92%, and I get 6.29% of the data is between those two. So that translates into 6.29% of the scores are between these two scores. All right, our last one. And you'll always be given either the part of the z-score table that you need and percentiles, or you'll have that entire one. And they're all the same. I mean, this is just a little clip of that one that I gave you early in this video. All right, I am supposed to look at this data that's normally distributed with a mean of 124, standard deviation of 17, and I'm finding the percent of people with readings between 115 and 133. So, z-score of 115 is 115 minus the mean, which is 124, divided by the standard deviation, which is 17, and that gives me negative 0.5. Then I have the z-score of 133. That's 133 minus the mean, which is 124, over the standard deviation, which is 17, and that gives us positive 0.5. So I'm finding the percentile between, or the percentage between negative 0.5, and positive 0.5. I will do that by taking the larger percent, 69.15%, and subtracting 30.85%. That tells me that 38.3% are between the scores of 115 and 133. All right, enjoy.